When it comes to chemical bonding, we have to start by understanding what the definition is about, and of course, the types of chemical bonding. Usually, these are the two main things that forms the core foundation of chemical bonding. By definition, we are simply saying chemical bonding is the force of attraction between two or more atoms, and principally they are divided into three main types, which you are going to look. The first one is the one that you can see on the board here, which is ionic bonding. The second one is covalent bonding, and the third one is called metallic bonding. As a start, we're going to start with ionic bonding, and we want to look at what exactly is ionic bonding. And remember, we maintain the definition that chemical bonding is the force of attraction between two atoms. And what exactly is ionic bonding about? So ionic bonding is about two things that are combining. There is metal. So we have a metal that is combining with a non-metal. Metal plus a non-metal. When these two attract, they form what is called ionic bonding. And basically, the main thing that we're just understanding here is what is the principle of attachment, because the principle of attachment differs with the type of bonding. For this principle is based on electron sharing and electron gaining. Now, before I start to explain whatever is happening on this diagram, I need you to just go back to a little bit on atomic structure so that you understand how these atoms are operating. Metals, by default, according to the periodic table, they are ranging from group 1 to group 3. And non-metals, they are ranging generally from group 5 to group 7. So metals are ranging from group 1 to group 3. Non-metals are ranging from group 5 to 7. What then this simply implies is that the way a metal operates is different from the way a non-metal would operate in terms of electrons. Metals operate by losing electrons, and non-metals operate by gaining electrons, which is the founding principle of ionic bonding. One has to lose and one has to gain. So basically, the one that is lost by the metal, so we are saying metals, according to this, they lose electrons, whilst non-metals actually gain electrons, which is the exact scenario that is happening in this diagram. With me here, I have sodium, which is in group 1, and chlorine, which is in group 7. These two, when they come together, since it's a combination of a metal and a non-metal, they then form an ionic bond. The first step, as you can see, I'm only indicating the outer shell electrons. Why is it that we are indicating the outer shell electrons? This is simply because only the outer shell, or rather the valence shell, which is the alternative name of outer shell, is the ones that are valence shell electrons are the ones that are involved in bonding. So if they are involved in bonding, we only have to indicate them and ignore the nucleus and the other shell electrons. So a metal will lose electrons based on the number of electrons that are in the outer shell. As you can see, sodium is in group 1. We have to also know again that based on this mnemonic, in case you might like it, for those who might have missed my class on atomic structure, where we say the group indicates the number of electrons in the outer shell, the period indicates the number of shells. Here we are focusing on the groups, which indicates the number of electrons. But anyways, back to our main business. So if you look at sodium, it has got 1 electron in the outer shell. Chlorine has got 7 electrons. According to operating principle for sodium, it simply means sodium will lose that electron. Once it loses that electron, what will happen? It is the exact electron that is going to be gained that is the same electron that is going to be gained by chlorine. And once it loses the electron again, it means the outer shell of that sodium is going to be lost. And now the new sodium that is going to be formed will assume the second from last shell, which has got 8 electrons, whilst the chlorine doesn't necessarily have to lose the outer shell, but it gains that electron and it has 1 extra electron, making it 8. So what is the main principle here? The main principle is to make sure that these two atoms are stable. So they are stable when they have got 8 electrons in the outer shell. So I'll include to say stable when having 8 electrons in the outer shell. This is why they are losing and gaining electrons. So from the second stage, you can see that sodium now has 8, chlorine now has 8. But the sodium has 8 because it has lost the outer shell, and the chlorine has 8 because it has gained. Which brings us to this last diagram. As you can see, once sodium loses, it now has more protons than electrons, which is basically 10 electrons because initially it has 11. And you can see chlorine now has more electrons than protons. This distribution will lead to the creation of electrostatic forces. Why are we saying electrostatic? Electrostatic, by definition, when we want to look at electrostatic force is a combination of what? Electrostatic force is a combination of positive and a negative. When a positive and a negative come close together, just like the principle opposite charges attract, they form an attraction which is backed by a type of force that is called electrostatic force. This is what we call ionic bonding. So one gains, one loses, they form an attraction. And additionally, we also need to talk about the idea of electronic configuration. If you see here, the electronic configuration is 281. If you really don't know much about configuration, watch my video about atomic structure. I'll put the link there so that you watch it as well. Here it will be 287. And because of the distortion of the gaining and losing of electrons between sodium and chlorine, what will happen is that the newly formed atoms, or rather ions, which we call, for sodium it's a cation, which will have 28, and then this one will have 288. So the other most important thing, when a sodium atom loses electrons, it immediately assumes the electronic configuration of the noble gas that is in the previous period. For example, sodium is in period 3, so it assumes the the electronic structure of the noble gas in period 2, which is neon. But for chlorine, since it's in period 3, according to my principal gaps period number of shells, it still has 3, it will assume the electronic structure of argon, and as a result they will be stable enough. And also talking about the other general properties of ionic compounds, because when ionic bonding happens, we form type of compounds known as ionic compounds. These ionic compounds, they have got high melting points and boiling points. Basically, some of the properties of ionic compounds that you need to understand at foundation level are simple. Number one, just know that all ionic compounds are soluble in water. Once you dissolve them, they form ions in water, which are mainly aqueous in solution. And the other thing you should know, that all ionic compounds are solid at room temperatures. And lastly, the idea about electrical conductivity. When it comes to electrical conductivity, there are two sides to it. Number one, you should know that ionic compounds, basically, they do not conduct electricity. However, when put in molten state, the electrons are free to move, or in a mature term, we say that electrons are delocalized, which enables molten compounds to conduct electricity.